let's now go on and look at the In-N-Out Burger sales. So McDonald's sales was all linear. That was all review of everything we had just covered in Unit 1. You know, In-N-Out Burger is a little different. It's not the same as what we covered in Unit 1. So, but let's see what is going on here. And so we find out that between 2010 and 2017, the US sales of In-N-Out Burger increased by approximately 4.83% each year. And we know that in 2017, In-N-Out Burger had $0.6478 billion in sales. Well, first of all, I can't just add the 4.83% to the 0.6478 because those are different units. This isn't billions of dollars. This is a percentage. I can't just add a percentage to a dollar amount. It's meaningless. The only thing I can add to a dollar amount is another dollar amount. But I can find out what is 4.83% of 0.6478. And so let me go over here. I'm going to clear out this information, get a new graph. And I am going to put my table in here just so I have a place to record stuff. I think for number 7, it was 0.6478. Okay, 0.6478. So I have that there. And I need to find out what was In-N-Out Burger sales in 2018. So I have to find out what is 4.83% of, if I write it in words here, 4.83% of 0.6478. How do I find that? Oh my gosh, look at that, Desmos just did it for us. I just typed it in like in regular language and it did it for us. Let's check and see if that's right. 0.6478, and to find the percentage of that, I'm going to multiply by 4.83%. Remember, 4.83% really means 4.83 divided by 100. That's what percent means. That percent sign actually looks like dividing by 100. So it's 4.83 divided by 100. And look at that. I get 0.03, the same thing. I could just type it in that way. Now, this is not my total sales, though, for the year 2018. That's just my increase of sales. I've increased by 4.83%. So this is my increase. So I would need to take and add that to this number to get a value there. So let's do that. I take 0.6478 and I add that to the I'm going to type it in like this. I'm going to add that to the 4.83% of, I love the way they do that, 0.6478. And this becomes my new output for the year 2018, 0.6791. Let's do 4 decimal spots. So you see what I did there? I started with this much, and then I added to that 4.83% of that much. Now, some of you, instead of dividing by 100, would like to do that with decimals, and that's just fine. So this is 0.46478 multiplied by 4.83 divided by 100 is 0.0483. If you did it that way, that's fine too. But then notice that just represents my increase. It does not represent my new output. So I had to take my current output and add that to the increased amount to get my new output. All right, so we just found one output. Let's go find the next one now. So the next one is, okay, well now again, I have to add 4.83%, but I'm not adding this 0.03128874 because that's 4.83% of this 0.6478 value. It's not 4.83% of this new output. So every year I'm going to have to find out what is my increase. So I'm going to take again this 0.6791 and I'm going to multiply that by 0.0483 to get my new increase. That's just my increase. Once again, I have to add it to my previous output to get my new output. So I'm going to take the 0.6791 and I'm going to add to that the 0.0328 and I get my next output of 0.7119. 0.7119. Beautiful. Okay. And let's do that one more time. So let's take this 0.7119 and let's find out what 4.83% is of that number. All right, this is my increase. So I'm going to take that 0.7119, my previous output, add that to 4.83% of itself, 0.344, looks like, because I'm rounding correctly. And I get this 0.7463. So I'm going to fill that in. 7463. All right, so these are my data entries for that table. So what did we do every time? Every time we found this 4.83% of a number and added that on. And we had to keep doing that. And a couple of you posted, I don't know how to make a formula for something that's recursive, something that relies on the value of the term before that. And yeah, that's really hard to do, but I'm going to kind of jump ahead here. Noah, I think it was Noah, was the one person who realized how to do this instead of in 2 steps, instead of finding out the 4.83% and then adding that on. Noah said, hey, you could just take that value, the 0.6478, and multiply that by 0.6478, multiply that by 1.0483, and oh my gosh, look at that value that we got. We got the exact same value. And then somebody challenged Noah on that and said, but where'd the 1 come from? Because 4.83%, when you change that to a decimal, is 0.0483. And I think Noah tried to explain that the 1 came from the original amount. And I'm going to take this, Desmos is so cool. Look, I'm going to take this and drag it down here. I'm going to show you where that 1 came from. Notice here, I have the 0.6478 in this term and in this term. This is the 100%. I could say 100% of, right? 100% of this number plus 4.83% of that same number gives me my final new output. So this 100% plus the 4.83% is 104.83. When I change that to a percent, 104.83 divided by 100 to change it into a decimal, because this is representing the percent, and this is the decimal form of that percent, is 1.0483. So we could just take this 1.0483 and multiply it by our initial starting value, and we get our output for the next year. This is the output in the year 2017. This one here is the output in the year 2018. So now we have a single step process in order to do that. Was I expecting you to be able to find that? Not necessarily. I was assuming that some of you might know that, and some of you would just do this 4.83% and then add that on, like many of you did. So that's good. But in order to be able to build a formula, which is something we're going to be doing in the next unit, we needed a one-step process in order to be able to do that. So just in summary, you can make it a two-step process. You can find your percentage increase and add that to your original whole amount. Or you can take the 100% plus the increase percent, add those together, and multiply by that to find the 104.83%. All right, we still need to look at problem number 3 though. Problem number 3 asks you to look at the rate of change. Rate of change is always defined as change in output over change in input. So we always have to look at, let me put it, the change in the output over the change in the input. That's how rate of change is defined. This 4.83% is not a rate of change. That's a growth rate, but it's not a rate of change. Rate of change literally means the rate, which is a ratio written as a fraction, of the changes, of the change in the output divided by the change in the input. So here I'll take this 0.6791 and subtract from that the 0.6478, and that's my change in my output. I divide that by the change in my input, which is just 8 minus 7, which is 1, and I get that for the rate of change between the year 2017 and the year 2018. Let's look and see what the rate of change is between the year 2018 and the year 2019. So again, I'll start with my change in my outputs, 0.7119 minus 0.6791. That's the change in my output. I divide that by the change in my input, and I get a rate of change between year 8 and year 9. And somebody pointed out that this is the average rate of change. And you're exactly right. It's the average rate of change between those 2 years. Okay, so then let's do one more. And here we say 0.7463 minus 0.7119. This is the change in my output, divide that by the change in my input, and I get 0.0344. Okay, so we see here, if we're looking at the rate of change, the rate of change is this value, and then this value, and then this value. So what can we say about the rate of change? Well, one thing we can say for sure is it's not constant, right? So we do not have a linear function here. We are not adding the exact same amount on each year as the years go by. What are we adding on? We're adding on a larger value each time as the years go by. So we would say that the rate of change is increasing. So not only is the function itself increasing, but the rate at which the function is increasing is also increasing. So let me say that one more time. We do not have a constant rate of change. We have a rate of change that is increasing. The amount that I add on each time is getting larger and larger with each additional year that goes by. Okay, so some of you might have already started looking at the next presentation. There's continuation of this in the next presentation, which probably says it a little more clearly than what I'm explaining here. But I just wanted you to see how I work through this problem and what I was hoping some of you would come back with. I definitely wanted you to look at problem 3, which was describing the rate of change. The first one had a constant rate of change. McDonald's, In-N-Out Burger, we're looking at an increasing rate of change. All right, if you have any questions, let me know, and I will talk to you later. Thanks.